this is a demonstration of two-way analysis of variance, particularly for between subjects design experiments or non-experiments. All right. Now, one thing that we need to know about the two-way analysis of variance or two-way ANOVA is that it is also used as a moderation analysis, particularly when both the independent variable and the hypothesized moderator are categorical, and particularly in this case they are dichotomous, meaning to say that there are only two levels or two categories for both the independent variable and the moderator. So I'm doing this with the assumption that more or less you are quite aware of what is moderation. Okay. All right. So this is our problem. In an experiment, high and low self-esteem subjects did a concept formation task, either alone or with an audience. Thus, absence or presence of an audience is a between subjects independent variable. Also, self-esteem between subject variables, as with the assumption that self-esteem is a stable trait or disposition of an individual, is also considered as another independent variable. So we are asked to use the data that will be given to determine the effects of self-esteem as well as the absence and presence of an audience on the number of errors committed in the concept formation task. And more than that, we will also look into the possible interaction between the level of self-esteem and the presence or absence of an audience. Okay, so we're talking about performance here, and probably it's conceptualized that those with high self-esteem would perform with lesser errors, and most likely those who perform without an audience would also perform with lesser errors. But we also would like to know whether there's an interaction, and particularly in this case, I'm choosing or I'm conceptualizing the presence or absence of an audience as my moderator, which means that if it's a moderator, then it is hypothesized to have an effect in the relationship between self-esteem and the number of errors. So maybe the impact of high or low self-esteem on the number of errors depend on whether or not there is an audience or there is no audience. Okay. So let's go to our data. So these are our variables. So the number of errors essentially is our dependent variable, and our two independent variables are self-esteem and audience. And among these two independent variables, I am conceptualizing audience as the moderator, or the one which will have or is theorized to have an effect on the relationship between self-esteem and the performance as measured by the number of errors. So to perform the two-way ANOVA, let's click on statistics. By the way, so you will notice that there are four groups. So one group has high self-esteem but performed without an audience. These are the errors they committed. The other treatment condition, the other group are those with high self-esteem but performed with an audience. These are their number of errors. The next group are those with low self-esteem and they performed without an audience. And lastly, those with low self-esteem and they performed with an audience. So to perform Dewey Anova, just click on Statistics, and then Anova, and then let's click on Factorial Anova, click OK. Then let's choose our variables. So the number of errors, of course, is our dependent variable, and our categorical factors or independent variables or predictors are self-esteem and audience. Let's click OK. Let's click OK again. So let's first take a look at all effects so that we can see. So essentially we have three hypotheses here. One, we are hypothesizing that self-esteem has an impact on the number of errors. We're also hypothesizing that the audience, their presence or absence, will have an impact on the number of errors. And third, we are hypothesizing for the interaction between self-esteem and audience. So let's check the results, the null hypothesis test results for those hypotheses. Alright, so it was mentioned before that Dewey Anova is very similar to multiple regression, and you can see here that in the result you have here an intercept which is quite similar to the output for multiple regression. However, we will not focus on that. We'll focus on these three. Okay, so this one is our result for the first hypothesis, and we ask or we hypothesize if self-esteem has an impact on the number of errors, and we can see that the result is significant with the probability value less than 0.05, which means that self-esteem has a significant impact in the number of errors. But we'll check later on with regard to what is the nature of this effect. Next, in terms of audience, we can see also that the probability value for the f-test is less than 0.05, which means that, again, audience has, their presence or absence has a significant effect on the number of errors committed by the participants. And lastly, so this self-esteem times audience, this refers to the interaction between self-esteem and audience, and likewise the result is significant. It's less than 0.05, and if audience is our moderator, then this is suggesting that the impact of self-esteem on the number of audience, on the number of errors, depend on whether there is an audience or there is no audience. So now all of these are significant, but we should not stop there. We have to look into the nature of these significant results. So what do we exactly mean by these? All right, now to give more meaning to those effects, let's click on means. So first, let's see for self-esteem. So let's choose self-esteem and then click on observed unweighted, because we have the same sample size for each of the groups. Okay, so what is it saying here? So we know that self-esteem has a significant impact on the number of errors, and those with high self-esteem, their average number of errors is 5, and those with low self-esteem, their average number of error is 9, which means that self-esteem has an impact on the number of errors, particularly those with low self-esteem or having low self-esteem result to more errors in the performance of the task. Okay. And then let's check for audience, because audience has a significant impact also in the number of errors. So click observed and weighted again, and there. So without an audience, the number of errors is 5, and with an audience, the average number of errors is 9. So having or the audience has a significant impact on the number of errors, particularly when there is an audience. It seems to lead to the commitment of more errors on the part of the participants. Okay. And lastly, let's look at the means of the interaction. All right. So we can see here that we said that the impact of high self-esteem or the impact of high self-esteem on the number of errors would depend on whether or not there is or there is no audience. And we can see here that without audience, the difference between in the number of errors between high and low self-esteem students is only about 4 and 6, only about 2 points is the difference. But when there is an audience, the difference in the number of errors between high and low self-esteem students is much bigger. It's 6 and 12. So there's a difference of about 6 errors. So it's already giving you a hint, but we have to make sure of this idea that it seems that, at least from the means, although this is not a guarantee, it's just a suggestion from the means, it seems that the impact of self-esteem on the number of errors seem to be more pronounced or more evident or more observable when there is an audience. Okay. So let's go back. Let's go back to quick. Let's check the graphs. So click all effects. Click on self-esteem. There's the plot. So this is the number of errors, and then high and low self-esteem, and you can see that for those with low self-esteem, they have more errors, significantly more errors at that. Let's click on Anova again, continue with current, all effects again, and for audience, let's check the plot. Click OK. There. So with audience, look at their number of errors, much higher than those without audience. And again, this is significant difference. We tested this a while ago. And then lastly, self-esteem and audience. Let's check the plots. Okay. Now, all right, so it's asking which is the x-axis and which is the line pattern. Normally, my suggestion is that whichever is the moderator, you assign that as the line pattern. Okay, so the moderator in my conceptualization is the audience. So and then the independent variable is self-esteem. So let's click OK. and there. So you can notice that, so the blue line represent without an audience, and the red line represent with an audience. And you can notice that those without an audience, the increase in the number of errors from high self-esteem to low self-esteem is just very not so much relative to the increase in the number of errors between high and self-esteem students when there is an audience. And normally it has been said that looking at plots visually, typically when there is no interaction, when there is no moderation, then we expect that these lines are more parallel, but it seems here that one is rather not quite inclined, but the other one is rather inclined. All right. Now, so to check, so we still don't know, is there a significant increase here? And is there a significant increase here? It's just that the increase here is much larger, or is there no significant difference here and there is a significant difference here between these two means? So that's the next thing that we will check. So to do that, let's go back to our Anova box, and then let's click on more results. Post hoc, and then let's click on self-esteem, audience interaction, and click on significant differences, and click on Toki HSD. All right. So we have here, you're quite familiar with this already, I suppose. So so let's compare those within. So high within and low within. So let's compare that. So again, remember, so these columns represent these rows as well. So let's compare low within with high within. High within is cell number 2. So high width rather. So there it is. Alright. And we can see that, so that's 4 and 2. There is a significant difference. So let's go to our plots. Where is that? Oh, it's gone. Let's check it later. So when there is an audience, the difference in the number of errors between those with high self-esteem and low self-esteem is significant. Okay. Now what about when there is no audience? So high without and low without. Okay. So 3 and 1. So where is that? 3, this one, and 1, and there. So it's not significant. So the difference in the number of errors between high and low self-esteem students, particularly when there is no audience, is not significantly different. Now to make more sense of that, let's go back to our plots. The one we produced a while ago. I think it's here. There. So with audience, check again. With audience, no, 2 and 4. there is a significant difference in the number of errors. So which means that for this red line representing with audience, there is a significant difference in the number of errors among high self-esteem students and low self-esteem students. But in the without audience conditions, high and low self-esteem students, their number of errors, so that's 1 and 3, 1 and 3, it's not significantly different, which means that this line is statistically a flat line. It's a bit inclined, but there is no significant difference in the means between these two groups. So this is a flat line, while this is an inclined line. There is a significant difference here, no significant difference here. So which means that audience moderated the effect of self-esteem on the number of errors, in the sense that self-esteem will have an impact on the number of errors, will have a significant impact on the number of errors, but only, at least in this case, only when there is the presence of an audience. But it does not really matter when there is no audience. There is not much impact. There is statistically no impact. Self-esteem has no impact on the number of errors when there is no audience. It only matters when there is an audience. So this is that is two-way ANOVA between subjects using Statistica.